Ladies and gentlemen, my name is Adam and I am a PhD student working at the Central European Institute of Technology in Brno. In this presentation, I would like to introduce our Brno urban dataset focused on localization and mapping in autonomous driving. First of all, let's take a look at similar work and why it might be interesting for you to take a look at our work. Of course, everyone who is dealing with the autonomous driving problems is familiar with the KITTI dataset. However, the KITTI or the Malaga datasets, for example, are nearly 1 decade old, and the sensory equipment used to record them is slowly becoming outdated. New datasets addressing this issue are regularly emerging. See, for example, the Waymo and the Apollo Space datasets. But there is no progression in sensor variety. Our dataset is recorded using up-to-date types of traditional sensors, such as cameras or lidars, but extends the state-of-the-art with differential RTK GNSS receiver for a direct heading estimation in global coordinate system, and thermal camera for enchanted perception in problematic conditions, when regular vision systems tend to fail. To our best knowledge, no other dataset provides this kind of measurements. The entire dataset has been created with self-localization and mapping in mind. We are making publicly available over 350 kilometers of roads, various traffic situations, and different environments. The dataset contains the city center, the highways, some country roads, some with the forest surrounding. Special scenarios such as loop closing, restricted perception in tunnels, and night driving are covered as well. We have split the data into 67 records, each tagged with the road type, GNSS signal quality, weather conditions, and daytime. Here you can see several examples of the camera records from different environments. The most important data sources are the 4 RGB cameras with 1920 x 1200 resolution recorded at 10 frames per second. 2 cameras are facing in front of the car and could be used for a stereo vision. The other 2 extends the lateral field of view to cover approximately 220 degrees angle around the car. One of the most interesting sensors of our dataset is forward-looking thermal camera. Sensing car surrounding in an infrared spectrum allows to better detect many objects of interest such as vulnerable road users. This greatly helps to increase overall robustness of the perception and scene interpretation system, especially in bad weather or lightning conditions. On the sides there are 2 3D lidars with 32 beams each one. Each sensor provides 10 scans per second with a total of approximately 1.2 million of points per second for the whole data acquisition platform. In the center of the frame, there is a 3D inertial measurement unit that provides information about linear acceleration, angular velocity, and magnetic field intensity in all 3 axes. Last, but not least important sensor is the GNSS receiver with a pair of differential antennas. The global position with precision of few centimeters is known for both of them, directly providing the heading vector of the entire car. This technique is used to stabilize localization estimation in 6 degrees of freedom, mostly in aerospace applications, but its adaptation to autonomous driving seems beneficial as well. Here you can see a brief overview of all sensors, the data types, frequencies, and the formats in which the data are stored. The recordings are structured in a dictionary tree with the data relevant to a single sensor located in a single folder. The videos and point clouds are stored in compressed files, while small size records such as timestamps, calibration parameters, or tags are stored in a human-readable form. We have put a special effort in data synchronization. All the data chunks are timestamped with a millisecond precision, which allows reliable fusion of data from different sensors during the processing. We have used GNSS timeframe as a reference for the entire system. Calibration parameters of the sensors and their mutual positions are available as a part of the dataset as well. Using them, you can easily use the data for stereo vision or to combine RGB cameras with thermal camera and the point cloud. During the recording, processing, and further utilization of the measured data, we have developed many little tools for various tasks. We provide them for public usage as well in an accompanying GitHub repository. All the data are available fully for free. You are welcome to visit the GitHub webpage, where you can also find a more detailed description of the entire project and the reference to a conference paper. Now let's take a look at some fancy data. For more information, please contact us directly.